Lesson 4.7, medians, altitudes, and perpendicular bisectors. It's a lot going on here, so I'm going to keep it short, not going into too much detail. You need to play with these to figure out what's going on. Median goes from a vertex, I'll go from B, top one, to the midpoint of the other side. It's a median. There's also one here. There's also one here. No, it's not drawn to scale. So every triangle has 3 medians. Just have to remember it. No secrets. Median goes from the vertex to the midpoint of the opposite side. Altitude goes from a vertex to the other side perpendicular. Again, altitude's like a median that it comes from the vertex, but it does not go to the midpoint. It's perpendicular to the other side. On a right triangle, you already have a 90-degree angle. So, if you look for the altitude here, it's at a right angle, but the altitude here and the altitude here, two of those altitudes are on the legs of the right triangle. Again, an altitude is from a vertex perpendicular to the other side. If you are in an obtuse triangle, you might have to actually go outside the triangle to get perpendicular. So you'd have to extend this line and extend a line down. And that would be the altitude from A. This bothers a lot of people because they say, well, how can it be outside the triangle? Nobody said it had to be inside the triangle. It just starts at the vertex and it's perpendicular to the other side. An obtuse triangle, that'll put it outside. And perpendicular bisector is not inside a triangle. We just find the midpoint. Bisector. This confuses people to no end. Goes through the midpoint. It's perpendicular. So that's a perpendicular bisector. Flip it over. We have some theorems that we base on all this information. One of them is the one we just did. Point A will be the same distance from B and C because it lies on the perpendicular bisector. A lot of people say, well, duh. And some other people say, well, why is this in here? And I say, looks familiar. Perpendicular bisector means it cuts it in half. We can use the whole triangle ADM is congruent to triangle, it's a B. ABM is congruent to triangle ACM by side angle side. Therefore, these are congruent by CPCTC, but we don't know that up front. We have to prove them first. So that's why it's here. But what you need to remember, perpendicular bisector is equidistant from points. This is just the converse, which makes sense. If you are equidistant from a point, then that point lies on the perpendicular bisector of a segment between you. And last but not least, angle bisectors. Got an angle. We have a bisector. Cuts it in half. I'm going off topic for a moment because this is a huge source of confusion. An angle bisector is not like a median. You look at it and say, no, no, no. If it bisects the angle, it'll go through the midpoint of the other side of a triangle. No, it will not. Sometimes it will, but generally it will not. So all this says is that AD is equidistant from AB and AM. If you have an angle bisector, you are equidistant from rays or segments. Again, this causes all sorts of problems. People say equidistant, no, it's points. No, wait, equidistant, no, it's rays. Angle bisector, every point on this angle bisector is the same distance from that ray. So you do not need to worry about points. It's just completely the same distance from the entire side of the angle bisector. This is the converse. If you are equidistant from the sides of an angle, you're on the angle bisector. It's a lot to absorb. Go try some problems, see if you can make sense of it. Good luck.